Okay, grade 12s. Let's look at the counting principle. This is now grade 12 probability. We revised in the previous 3 lessons. We looked at revision of grade 10 and 11. It's important that you master those concepts of Venn diagrams and tree diagrams, independent, dependent, mutually exclusive, inclusive, complementary, exhaustive. All those principles are very important. But now the counting principle, I think, is so exciting. Now watch this. And it seems to be very difficult. Now I'm going to make this very simple for you. It seems to be difficult, but it's not. Now watch this. I'm going to start off with something that will scare you. It says if one operation can be done in m ways, and a second operation can be done in n ways, then the total possible number of different ways in which both operations can be done is m times m, enough to make you want to run away. Now, hold on to this. It's actually very simple. Let's have a look at something. Okay, it's 2 operations. The one operation will be that a coin is tossed, and then a die is rolled. Okay, now, watch this. There's 12 possible outcomes. We could get a head on the coin, followed by 1 on the die. We could get a head first and then followed by the number 2 on the die. Remember, if you don't know what a die is, that is going to be that little cube thing, and you might have the number like this, it's numbered, and you might have the number 1 there, and so it's on there, and then the coin, obviously heads and tails. Okay, so that's, I'm assuming you know from earlier years. Okay, so you could get a head followed by the number 1 on the die, a head followed by 2, a head followed by 3, a head by 4, a head followed by 5, a head followed by the number 6. Or you could have got a tail followed by 1, the number 1 on the die, a tail on the coin, 2 on the die, a tail on the coin, 3 on the die, tail 4, tail 5, and tail 6. Now look at this. There's 2, 4, 6, 8, 10. There's 12 possible outcomes. Now how does the counting principle work? It's very easy. What we can say is for the coin, how many possible outcomes are there? There are 2 outcomes, heads or tails. And for the die, okay, for the die, it's going to be, there's basically 6. You could pick the number 1, 2, 3, 4, 5, 6 on that die. Like there you can see 1 is facing up there. Okay, now we know that there's 12 outcomes. So how does the fundamental counting principle work? It says for throwing the coin or tossing the coin, there are 2 outcomes. For the die, there are 6. And the total possible outcomes would be 12, which is these guys, 6 there and 6 at the bottom. So if you multiply these, it's 12 possible outcomes. So there's 2 possible outcomes for heads, for the coin, which is heads and tails, and there's 6 possible outcomes for the die, which is 1, 2, 3, 4, 5, and 6. Okay, so that's where they talk m times n. Okay, and that is what we call the counting principle. Now, if you're still not sure, let's have a look at a second example. I'll show you how easy this is. And this time, we're going to have 2 operations. It's going to be a choice 1 and a choice 2 in a breakfast menu. Now, a breakfast menu is made up as follows. Choice 1, you could eat oats, I'm getting hungry, Millie Meal, cornflakes, Rice Krispies. So you've got to choose 1 from each option. So I could have chosen oats, or I could choose Millie Meal. Then your second choice, you can choose fried eggs, scrambled eggs, or poached eggs. So how many possible choices do you have in choice 1? There's 1, 2, 3, there are 4 choices here. And here we have 3 choices. Okay, eggs that are fried, scrambled, or poached. Now, how many different breakfast meals can be made using these choices? Okay, well, what you could do is, if we think about it clearly, we could start off by saying, let's have oats, and that's the first choice, with fried eggs. with the fried eggs. Okay. Or we could have oats and scrambled eggs there. Or we could choose oats as our first choice, and our second choice could be poached eggs. So there's 3 options there. Then you could have, maybe if you look at the next one, you could have milli meal, and you could then have fried eggs. Or you could have milli meal and choose scrambled eggs. Okay, scrambled there. My spelling's bad. Let's tidy that. It looks ugly. Let's tidy that up quickly. So it's scrambled eggs. Or you could have milli meal and poached eggs. You pick one from each choice. Milli meal with poached. Then you go cornflakes with all of those 3. So we would have now cornflakes, and you could then have fried eggs. That's one option. Then you could have cornflakes first, and then in your second option you could have scrambled eggs. Okay, then you could have cornflakes, and you could have then poached eggs. Now look at that, another 3 options. Or you could go for the Rice Krispies. Look at that. So we could have Rice Krispies. See there? Watch how easy this is. With fried eggs. You could have Rice Krispies with scrambled eggs. See that there? Scrambled eggs. Or you could have Rice Krispies with poached eggs. Now, how many possible choices do you have, or meal? Let's look at the breakfast meal choices. You've got 3, and these 3, the cornflakes 3, and the Rice Krispies. That is a total of 12 possible meals. Now, instead of doing it like the saying oats with fried, scrambled, poached, mini meal with fried, scrambled, poached, corn with fried, scrambled, poached, Rice Krispies with the fried, the scrambled, and the poached, we know that there's 12, but it's much easier. All you need to do from the counting principle, you'll say, is 4 in choice 1 multiplied by 3 in choice 2, which is 12 possible meal combinations, where you have 1 from choice 1, 1 from choice 2. There are basically 4 choices in choice 1, which would be the oats, the milli meal, the cornflakes, and the Rice Krispies. And in choice 2, you have 3 choices: fried, scrambled, or poached. Pick 1 from each. You have 4 in the first choice, 3 in the second choice. So 4 times 3 is 12 possible meals, breakfast meals, 1 from each choice, that can be done.